Piece of operating system. In today's video, we are going to see about what is the memory management and what are all the basic concepts we require to do the memory management in terms of operating system. So, what is the memory management means? In our memory management topic, we are going to see about mainly we are going to allocate and deallocate of the memory, and we do the memory mapping from logical to the physical addresses. And for memory mapping, we have a different memory mapping techniques like paging, segmentation with paging. And to do the memory mapping, we have the concept like swapping and memory protection and fragmentation, virtual memory. These are all the things have required to do the memory mapping and do the allocation of and deallocation of the memory. So what is the memory management? To run a program, it must be brought into memory. So before running the program, all the programs in the secondary memory, that is in the job queue. From the job queue, some of the programs are ready to run is given bring into the ready queue. From the ready queue, the CPU select the process and execute that and select the process and do the execution of the in a particular process in memory. So from the input queue, the collection of processes are bring into the memory. From the job queue, the collection of processes are brought into memory to run the program. So this is the basic concept of memory management. In the memory management, we have each process have a separate memory space, and the protection can be achieved through the base register and limit register. For example, for every process we have a specified memory space in the physical memory. So in the physical memory, the memory space is represented in terms of the base address and limit address. So what is the base address means? The starting address of the particular process. The limit register shows what is the size of the process. Based upon that, the production is indicated and specified in terms of physical address space. Only the operating system can set the base and limit registers. The CPU requires an absolute memory location M. The hardware verifies that whether the base is less than or equal to memory is less than the base plus limit. If it is, means it is do the if the thing is not in the case, means the hardware trap the error to the operating system. So this is the thing, the CPU generated the logical address. That logical address is greater than and also add with that limit registers that could be in the particular memory space. If it is, means it go to the particular memory, it's stored in the particular memory. Otherwise it trap the operating system, it is an error. So in the memory mapping system, we are do the different types of three types of address binding. That is the memory the memory management. We are going to map our logical address to the physical address. For that mapping, the three types of addresses are generated. One is a compile time address, and other one is a load time address and execution time address. So the compile time address means it generates the absolute code, and load time it generates the relocatable code, and execution time that relocatable is brought into the physical memory. So this is the address binding of normal any programming language executions. First, the source program is compiled or assembled by the assembler or compiler and generate the object module, and from the object module, the linker linking all the modules into the single program. Finally, the loader load that program into the physical memory. So the three ways of in the three process, the different addresses are generated. Next, we will see what is the logical and physical address space. The logical address is generated by the CPU, and physical address is generated by the memory management unit. So there is a mapping between the logical and physical address. So the logical address space is a combination of the address plus the offset, and also the physical address space is the combination of an physical address and is an offset. What is a memory management unit? That memory management is a unit is a hardware device that maps our virtual to the physical memory. So here the dynamic relocation using the relocation register. Here the CPU generate the logical address. That logical address is added with the relocation register and produces the physical address. That physical address is stored in the physical memory. Next we have the concept of linking and loading. So what is the linking means? The linking is postponed until the execution time. In that linking, all the shared libraries are added into the program. That process is done by the translator linker. Next is the loading. Once all the programs are linking, that linked programs are loaded into the physical memory. That could be generated by the, that could be done by the loader. So this is the dynamic linking and loading. So the linker collect the object module and also the object libraries and combined one program. That one program is converted into go to the loader. That loader is load that program in the physical memory. Next we have the concept of overlays. So what is the overlays means? We cannot kept all the process address in the all the process total size in the physical memory. So keep in memory only those instruction and data is required at time of executions. So that thing is called it as a overlays. Overlays means only whenever the necessary instruction only loaded into the physical memory. So in that physical memory we have the space of operating system and the sum and the process sizes, and also what is the for example you have a process 1 and process 2 means we cannot accommodate both the process in the memory. So what are all the common things in the both the process that could be stored in the permanent in the memory. So whenever the process 1 is required means that process 1 is loaded. When the process 2 is required means the process 2 is loaded. This is the two pass compilations in the overlays concept. So herewith I explained that in this video I explained what is the basic memory management activities in terms of operating systems, that is the allocation and deallocation. For the allocation and deallocation we have that several for the allocation and deallocations we have to move the process from secondary to the main memory, and there is a two types of memory management techniques like continuous and non-continuous. So the continuous means in the physical there is a logical address is in the continuous phase. In the physical memory it is not in the non-continuous. For that memory management architecture we have the paging, segmentation and segmentation with paging. For the memory management we have to know about the basic concept of what is that address binding, what are all the three types of addresses, and what is the dynamic loading, linking and overlays. I hope you will understand the basic concept need for in the memory management technique. Thank you.